In this class, I'm going to teach you everything there is to know about algebra in a step-by-step approach. I'm going to start with some refreshers and some basics, so bear with me. It's good to get some of these concepts down in order to progress. See, in mathematics, whenever you learn math, you need to develop a foundation. And like anything, if you don't have a solid foundation, then you kind of lose your way. The whole structure becomes unstable. So with math, you have to build upon knowledge that you've learned prior in order to gain more knowledge. So if you don't understand a concept completely, if you don't really grasp it, you have to go back and learn it and truly understand it. Now, everybody learns in a different way. So sometimes what I explain to you won't make sense. Try to look it up in another way. You have Google, you have searching on the internet, you have all kinds of resources. You have your school resources, you have other folks, you have other adults that probably know this stuff. So get different perspectives if you don't quite understand a concept. Also, feel free to comment and I'll try to address those concerns as well. With Algebra 1, we're going to learn from number lines all the way to algebraic equations. And I'll start off pretty fast with just kind of getting us up to speed with what numbers really are and how they're represented on a number line. As you can see here, I have a number line right here. The label is the number line. Let me just make sure I have my pen working. So we have a number line. What is a number line? It's nothing more than a way to represent numbers and their relationships with each other. So this, I'm calling it a number line, but I haven't really described it too much. I'm going to find a spot on here and pick a 0 or an origin. So I'm going to say the 0 is here. So this is a 0, and it's also known as the origin. So I'll just put a little arrow here and call it origin, the origin. That's where we originate, the 0 is. Everything to the right of the origin, so everything to the right is a positive number, and everything to the left of the origin is a negative number. That's simple. Now, I can choose arbitrarily what these numbers are, but just to make it easy, I'm going to call them integers. I'm going to say that it starts off with a 1, and then a 2, and so forth, all the way down to infinity, if I wanted to draw that out, right? And then over here would be -1, -2, -3, etc., etc. So we have a number line, we have a relationship. The good thing about this particular number line is that the unit length between the 2 and the 3, between these integers, is the same as the unit length between the 2 and the 1. So this distance here is the same distance as this distance here, and so forth and so forth. All these little units are the same length. Now, on the number lines that you might come across in the future, they may not necessarily be equal lengths, and they may not arbitrarily be the same. 1 to a 2 has a length that looks like this amount of space between them, and then a 2 to a 3 might have a larger space. Not everything has to be drawn to scale or proportionate. Scale would be like saying, you know, if this is 1 inch, it's not really 1 inch, because on your screen, it might be on a mobile phone, it might be a half a centimeter, it might be a centimeter, it might be 2 centimeters. So everybody's screen is different. But if it was to scale, then it would be actually, if I said this is 1 inch, it would literally be 1 inch when you're looking at it. So that would be scaling. Proportions are, hey, between here and here is the same as between here and here, and here and here. They're proportionate. They're all the same unit length all the way across. So this is a proportionate, but not necessarily to scale. Hope that resonates with you. Okay, so this is the number line. Now, a couple of key facts about this number line. This number line contains all real numbers. So you might see the letter R, it stands for real. All real numbers are on this number line. What's a real number? I'm not going to go into too many details, but any number you can think of is a real number, basically, right? 2.5 is a real number. 2/3 is a real number. 4/5 is a real number. Things like that. Irrational numbers like pi. If 3 is here, pi might be 3.14159 approximately. So pi might be sitting right here. And if you blow that up, you know, I'm just gonna put a little thing here and say that's pi, which is approximately. So this little symbol here is what I use to denote approximately. 3.1415 59 ... goes on forever. It never repeats. There's no pattern. So that's an irrational number, but it's a real number. And because it's a number and a real number, it's on my real number line. So it is on here. This number line contains an infinite number of points. And every single point is on this line. You just have to imagine it because we can't obviously express that by drawing it. So every single number is on this number line. And remember, the distance between each one of these is called the unit length. I could label these not just with numbers, I could put letters. I could say this is the letter A right here at this point on the number line right here. And this is a letter B right here. And I can ask you questions like, what's the distance between A and B? Well, you know that each unit across is length 1. So if you start from A to B, you can say 1, 2. So it's a unit length of 2. So from A to B is 2. From B to A is 2. It goes both directions. Now when you're talking about length, length is only positive. So if I had a number C, we're going to call it C. If we have a letter C that denotes right here where the negative 3 is, and I say, what's the length between A and C? You just count them out. So you'd say 1, 2, 3, 4, 5, 6, 7, 8, 9. So from A to C is 9. And one way to denote that is you can just say AC is equal to 9 with the little brackets. But don't worry about the notations at this point. Okay, and that is basically what a number line is. And every real number is there. The reason why I showed you this was just to represent some of these concepts and relationships. I'll see you at the next lesson.